In this video, we are going to learn about variables scope. In a programming language, the scope of a variable refers to the region of the code where the variable is accessible. This means that the variable can be used and manipulated within that specific region of code. The scope of a variable is determined by where it is declared and can vary depending on the programming language and its specific rules for variable declaration and accessibility. Understanding the concept of variable scope is an important skill for programmers of any level because it can affect how your program behaves and avoid error or bugs. There are two main types of variable scope in Python: global and local. To better understand the implication of the scope of a variable, we are going to look at two code examples. In this program, the function incrementBy adds the sum y to the variable x and returns the result of the sum. Executing the program works without any issues, and the output is 13 and 10 as the variable x is not modified by the function. However, what I really wanted is for the variable x to be modified, and I expected to have the output 13 and 13. This can be easily corrected by refactoring the code as follows. In this program, the function is modifying the variable x by adding y to itself and then returning x. However, when running the code, it results in an error. Unbound local error, local variable x referenced before assignment on line 3. The interpreter tells me that on the right-hand side of the assignment on line 3, the variable x is not defined. I must say I'm quite confused here. I have defined x on line 1, so what's the problem? Clearly, the interpreter is wrong. As in most cases, the interpreter is not wrong and the issue is mine. I do not understand the scope of a variable. For the interpreter, the variable x defined on line 1 is not the same as the one used in line 3. The variable x defined on line 1 is a global variable, whereas the variable x used on line 3 is a local variable. In a way, the interpreter reads the code as if it was written like that. Now we can see clearly that on line 3, I am referencing the variable local x before it has been assigned a value. I can hear you say, but wait a minute here. In the first program, the interpreter did not complain when I referenced x within the function. So what is this black magic here? This will come clearer later in the video. First, we need to define what a global variable is. Global variables are variables that are defined within a module but outside any function and can be accessed by any part of the code in that module. For example, let's say we have a global variable called x and we assign it a value 10. Now we can use x anywhere in our code and it will always have the value 10 until we assign it another value. For example, we can print x or use it in a calculation or pass it as an argument to a function. However, global variables can also be modified by any part of the code, which can cause unexpected result or conflict. For example, if we have another function that changes the value of x, note the statement on line 3. We use a global keyword to tell Python that we want to use a global variable x, not a local one. Now, when we call this function, the value of x will change for the remainder of the program, not just inside the function. This can be confusing and problematic, especially if you have a large and complex program with many functions and variables. Therefore, it is generally recommended to avoid using global variables unless you really need them or they represent a constant that should not be changed during the execution of the program, and to use descriptive and unique names for them to avoid conflict. Now that we have a better understanding of global variables, we can define what a local variable is. Local variables are variables that are defined inside a function and can only be accessed by that function. For example, let's say we have a function that takes a number as an input and returns its square. Now we can use this function to calculate the square of any number, and it will always work as expected. However, we cannot access the local variable result outside the function, because it only exists inside the function. When the function terminates, there are no more references to the variable result. Trying to print result gives an error. Name result is not defined. This means we cannot access the variable result outside the function square. Local variables are useful because they allow us to create temporary values that are only relevant for a specific task or calculation, and they do not interfere with other parts of the code. Now let's consider the following code. What is the output? The output is not 5 and 4 as one might expect. It is 2 and 4. Functions parameters are local variables that are only visible within the function. In our example, the variable n used within the function is a local variable, and its value on line 4 is the value of the argument passed to the function on line 7, that is, the value 2. Our code has a name conflict. A name conflict in Python, also known as a name collision, occurs when two or more variables with the same name are defined in different scopes. This can cause confusion and unexpected behavior because it can be unclear which variable is being referred to when the name is used. In our example, we say that the local variable n hides the global variable n. In other words, the global variable n is ignored inside the function because Python assumes that we want to use the local one. This can be confusing and misleading, especially if we expect n to have a certain value. Remember the first two samples of code we used at the beginning of the video? In the top sample, the interpreter recognizes x as a global variable, but in the second, it recognizes it as a local variable. Why? It is because we use the assignment operator on x in the second code. When you use an assignment operator in the body of a function, the variable on the left-hand side of the assignment is considered a local variable, except if it is explicitly stated that it refers to the global variable using the global keyword. To avoid this problem, we should use different names for our local and global variable, or use the global keyword inside the function if we want to use or modify the global variable. My advice? Do not use global variable within a function unless it represents a constant like pi. An enclosing scope in Python refers to the scope of a variable that is defined in an outer function but is not global. This type of scope can be observed when you nest functions inside other functions. For example, the variable x within the inner function is neither global nor local. It is said to be in the enclosing scope function, outer function. This means that the nested function, inner function, can access the variable x from its enclosing scope, which is the outer function, outer function. However, if you want to modify the value of x within the nested function, you need to use the non-local keyword like so. In this example, the variable x on line 6 refers to the variable x declared on line 2. Therefore, the output of the program is 10 followed by 20. Let's see how it works with an example. The aim of the program is to update a list of accounts by adding a year interest. The first comment that should come to mind is that it is a convoluted code far too complicated for what we want to achieve. However, it will help us understand the concept of enclosing scope and non-local variable. The function compute interest is nested within the function update all accounts. Within the function compute interest, the variable amount refers to the non-local variable defined on line 8. The variable rate refers to the non-local variable rate defined in the parameters of update all account on line 1. Finally, the variable interest is a local variable. When executing line 18, a new frame is created, and within that frame, a function object is created for the function computeInterest. When line 11 is executed, a new frame is created. Do note the reference parent equal f1, stating that the function object can access the enclosing variable defined in the frame f1. When executing line 5, the function can access the value of amount and rate from the frame f1 and compute the interest. Once executed, you can see the newly declared local variable interest with an assigned value of 5. When line 6 is evaluated, notice that it is the variable amount from the frame f1 that is modified, not a local variable. Once completed, the program continues its execution from line 12 and updates the list of accounts. The same process repeats another 2 times before the program terminates. When you use a variable name in Python, the interpreter searches for the variable in different scopes using the LEGB rules. This rule specifies the order in which Python looks for variable name in different scopes. The acronym LEGB stands for local, enclosing, global, and built-in scopes. Here is how Python searches for variable name using the LEGB rules. Python first looks for the variable name in the local scope, which is the innermost scope that contains the code currently being executed. This includes any local variable and parameters defined within the current function or block of code. If the variable is not found in the local scope, Python then looks for it in any enclosing scope, which are the scope of any outer function that contains the current function. This search continues outward through all enclosing scope until the variable name is found or until there are no more enclosing scopes to search. If the variable name is not found in any local or enclosing scopes, Python then looks for it in the global scope, which contains any variable defined at the top level of the program, that is, outside of any function. Finally, if the variable name is not found in any local, enclosing, or global scope, Python looks for it in the built-in scope, which contains any built-in variable and function provided by Python. If the variable name is not found in any of these scopes, Python raises a name error indicating that the variable name is not defined. In summary, the scope of a variable refers to the region of the code where the variable is accessible. This means that the variable can be used and manipulated within that specific region of code. The scope of the variable is determined by where it is declared. There are 2 main types of variable scope in Python: global and local. Global variables are defined outside any function and can be accessed by any part of the code. Local variables are defined inside a function and can only be accessed by that function. There is also a third one, the enclosing scope, which refers to variables defined in an outer function in nested function. We should be careful to avoid name collision in our code and use descriptive and unique names for our variables. This is the 3rd time I mentioned the following in this video, so it must be quite important. Avoid using global variable within a function body, except if it represents a constant like pi. In addition, understanding the LEGB rule can help you write more reliable and maintainable programs by avoiding or minimizing bugs related to name collision and bad use of global name across your program. Thank you for watching and see you in the next video.